Yeah, let's start the class. Now I will share my screen.
Good morning, sir.
Good morning. Yeah, yeah. So let me go on. I will be a bit faster in pace because I need to cover the majority of the questions. So first, let me start with the first question. Right here, we have got some marks that I need to create a exercise scatter plot for the marks scored by the students in external and in internal and external examination for three different subjects separately, and also I need to plot a comparison graph of internal and external marks scored by the students in all the three subjects. So first going on to that, this we need to tabulate in the Excel. So majority of the time I will be using the templates which I have already created in order to save the time. Right. So I have created a tabular column here, something like this, right? As per the data which he has given in the question, right? I have created that. Now I need to draw the graphs. Here we comes the total five graphs will come. Second. Sorry, there was an emergency call. Right. I don't need this minimum. Right. Right now, I need to draw the graphs. As mentioned, I need to draw the marks scored by the students in internal and external examination for maths and material science. So, mean that I should have graphs of for mathematics internal and external, for material science internal and external, and for thermodynamics internal and external, and also a comparison graph of internal marks scored by the students for all these three, and the external marks scored by the student for all these three subjects. So totally we will get a total five graphs. So I will open up. Now I will go to the insert, right? I have my scatter plot, right? Scatter and smooth line markups. And there might be some variations because the version of Excel which I am using is Office 365, and the versions which you will be using might be the other versions. So appropriately, but the comments remain the same, but the location of comments will vary. That's it. So I will right click on this. I will go to the select data. Right. First, the series name I can give thermodynamics. Right. Series X remains the roll number. series Y. What I can take this thermodynamics. Let's take rather than I can give the series name being external examination. Right? Click on OK. The same thing. One more I will draw. And my X series values remains the same. The Y series, okay, right? This I got it. Now for this, I need to draw the axis title, right? Primary horizontal, primary vertical, chart title. Above the chart, I can give it data labels. I don't need error bar, grid lines, trend line. I don't need that. Or I can give legend here. Right? This I can double click on this. This the x-axis is my roll number, and my y-axis will be marks scored by the students. This is external marks, internal marks. This chart title I can give. I can write a variation of external and internal examination of thermodynamics subject. Right? So I can select this. I can change the font. Right? Rather than in order because it is in the increment of 2 is there. You can right click on that. Right? You can select the format axis. You can give the measure being 1. Right? For every one, the increment will be there. Like that, you can this you need to bold it. You can bold if required, right? And the roll number, and this also you need to bold. You can select and you can bold. These are all the formatting part, right? This is the one graph. Similarly, similarly, I need to draw it for the mathematics 3 and material science also. So I will. What I'll do is I will not because that template which I have already created, right? I don't need to draw it again. Right? So what I'll do is I will copy this figure and I will paste this figure somewhere, right? Here, what I will do is I will right click on that. I will choose the select data and I will edit the data. Here, external mass is already there and internal mass is already there, but these two corresponds to thermodynamic subject, right? Two options are there. One, I can remove and I can do it, or I can edit that, right? I can edit that. External marks remain the same, but this I will vary x. The range remains the same, but this y series y I will choose mathematics. Click on OK. In the similar, go to the internal, edit this. OK, OK. This is updated. This graph is automatically updated, and you can change mathematics 3. Right? So this saves you a lot of time. This saves you a lot of time. Similarly, I will copy this and I will paste this somewhere and I will select the data, edit it. Now I will choose I will choose the series Y values being material science and also for internals also for series Y values, I will choose a material science. Click on OK. Okay. This, you can double click on this. right? So I have completed my three, right? Next, I need to draw the two more comparison. Two more comparison mean that internal examination marks for all three subjects and external examination marks for all three subjects, right? So now what I'll do is I will copy this and I will paste this somewhere else, right? Here I can draw variation of external examination, external examination marks, external examination marks of three subjects, something, right? Of three subjects. Now I will right click on this, select the data. Now I don't need internal and external. Rather than I need my series name is external examination, right? Rather than that external examination marks full, sorry, I need that's not the series name. The series name will be my thermodynamics. X values remains 1 to 15 and Y values remains this. Click on OK. Similarly, I will add one more. Mathematics 3 is my series name and my X values and Y values. Click on OK. Third one, material science, X values, the similar thing, Y values. Now you can see that, right? Variation of external examination marks of three subjects. So thermodynamics, mathematics 3, and also material science. Similarly, I can copy and I can paste it somewhere. Here, rather than external examination, let's choose it to be internal examination. And I will right click on this, select the data. I will edit this. Thermodynamics, internal will be this. For mathematics 3, internal will be this. And for material science, internal. Click on OK. OK. This updates. Right? So this completes your first question. That is, I need to create a XY scatter plot for the marks scored by the students in the internal and external examination for three subjects separately, and also plot the comparison graph of internal marks and external marks scored by the students in all three subjects. Right? So all those questions are very easy, right? It's only requires a bit practice. So that's the first one done. Let me move on to the second one. Right? Draw a bar chart for the above mentioned students' marks and how many students have scored the marks in the range of 0 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50 in external examination. So the data remains the same, right? For this, how many students, I need to draw the comparison graph, right? I need to draw the comparison. For example, I will show the solution of that also. Right? Here I have, right? For this subject, right? How many students have scored in the range of 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50 in three different subjects, right? So let me show that. My second question, I will move it. Right? So I have created the same tabular column and also additionally, I have created some more thing that is the range is 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50 and the three subjects. Right? Here I need to count that. I need to count rather than counting, right? I can make use of a count if function, right? I have one function called as a count if yes, right? Is subjected to multiple conditions, right? Count if yes, criteria one is This is the range, comma. What is the criteria? Criteria should be greater than 0. So let's take greater than or equal to 0. This is my criteria 1, right? Next, second criteria is the same thing, but my condition is less than or equal to 10, right? I'm counting the numbers from greater than or equal to 0, and it should be less than or equal to 10. Less than or equal to 10. I can see 8 members are there. I can see 8 members are there, right? So now what I can do it, fix this. Let me fix this because if I drag that, it will change. It should not change for me. So now I can take it. This is 11 to 20, right? Greater than 10, less than or equal to 20, right? Next, this one, g- greater than 20, means that from 21 onwards, less than or equal to 30. Next, this is greater than 30 and less than or equal to 40. Now, this is greater than 40, less than or equal to 50, right? The same concept which I have used. I have taken a multiple countif function, that is countif subjected to some condition, multiple constraints. This is my one constraint and this is my second constraint. If required, I can add one more constraint, right? If required, I can add one more constraint, right? So this is for thermodynamics. Like this, the same you should work on for the this also, mathematics 3 also. What is the mathematics 3? Countif, yes, right? This is the range, comma, right? It should be greater than or equal to 0, comma, the same condition. What is the constraint? It should be less than or equal to 10. Less than or equal to 10. I can fix this. Sorry. So this constraint will be greater than 10, less than or equal to 20. This is greater than 20, less than or equal to 30. This
Sir,
is greater than 30 and less than or equal to 40.
a small doubt, sir.
1 second. 1 second. Let me complete this. 40 less than or equal to 50. The same thing. I will move on to this. Countif, yes. My third range will be material science, comma, constraints. It should be less than or equal to, sorry, greater than or equal to 0, comma, same range, comma, it should be less than or equal to 10. Let me fix that. So this will be greater than 10, less than or equal to 20. This is greater than 20, less than or equal to 30. This is greater than 30, less than or equal to 40. greater than 40, less than or equal to 50. Yes, you can ask me that question. I think someone might have tried to ask me some question.
Yes, sir. In second range, you are starting from range 10 only, no, sir. But
No,
the count should be from 11.
no. I'll tell you. Here, I am taking greater than 10. I am not mentioning greater than or equal to 10. Greater than 10 means that 10 will not get counted, right? Greater than 10 ಅಂದ್ರೆ 11 ಇರಬೇಕು, 12 ಇರಬೇಕು, till,
Okay, got it, sir.
right?
Okay, got it.
There, I have not mentioned greater than or equal to, right? In the first condition, I have taken greater than or equal to 0, right? If I taken only greater than, if I take only greater than, 0 will not be counted there.
Okay,
0 will
got it,
not
sir.
be counted there. We need to check that,
Got it, sir.
right? If I select totally, the total sum should be 15. Here you can see it. The total sum, it should be because we have 15 students are there. Here also, if you take up a sum, it should be 15. Got the point? So
Yes, sir.
now I
Got it,
need
sir.
to draw a bar graph. Now I need to draw a bar graph. So let me go to the insert. I have my bar graph here, right? I can take a 2D clustered column. I will choose right click on that, select the data, add legend. First series will be thermodynamics. Right? Click on OK. Second series, choose it to be a mathematics. Plot it. And the third series you added material science. And now here on the horizontal axis, it should not be a 1, 2, 3, 4, 5 for us. It is a range. So now what I can do it under horizontal category axis labels, I can click on edit. Now I will choose the axis range labels. You can see that you got instead of earlier it was 1, 2, 3, 4, 5. Rather than that, we got 0 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. Click on OK. Now I need to add axis titles, chart title, right? Legend if required. Yes, legend. Let's add. Right? Let's format that a bit. Right? So this horizontal axis is range, and the y-axis is number of students. So this title you can, I will copy it down. Sorry, because if I type it, it requires some time. Right? Variation of marks scored by the student. I'll take this axis to be bold, this to be bold, and this also to be bold. Right? This is the graph that is variation of marks scored by the students in the range of 0 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50 for all three subjects. That is mathematics, thermodynamics, and the material science. So this completes my second question. Now,
Sir, only for
yeah,
hello.
tell me.
Sir, only for external examination marks only, sir.
Yes, that depends upon the question. If in the question, if
Okay.
they ask you to draw the internal examination marks, you need to draw it.
Okay, sir.
Right? But here, question if I take it, draw the bar chart for the above mentioned students' marks. How many students have scored in the marks in the range of 0 to 10, so and so, in external examination?
Okay, sir.
Right? Based on the question,
Okay.
we need to. If the question in the question paper, if they are given you to do the external examination, you do it. If they do it, if they ask to do it in the internal examination, do it. If they ask both, you do both.
Okay, sir.
Right? Based on the question,
Okay.
we need to go ahead.
Okay, sir.
This is the analytical how you need to draw. Right? This is the analytical how you need to draw. Graph sheet will be provided by us only. And my third question. Yeah, let's move on to the third. That is draw the XY scatter plot for the marks scored by the students in the external and the internal examination with the two y-axis for so and so subjects. This is very simple, right? Which is similar to that of the first one, but only there's a slight change is there, right? So right. So now what I'll do is first I will retain this. Sorry, I don't want to retain. Scatter with smooth markup. I right click on that, select the data. Let's choose it for the delete this. Select the data. I'll take a variation of two external marks, right? Done. Done. So now series name. Let's take external, internal. Rather than take this series X values, you take this. Series Y values. This is for thermodynamics. Click on OK. Click on OK. And I will draw internal examination marks also. Why? Sorry. This should be roll number. Right? So click on OK. Now I need access titles. Now I need access title, chart title, legend. Right? So now what I can do it. Well, let me do it. This I can take it to the roll number, and this is a marks scored by the students, right? Or rather than that, a second, marks scored by the internal, right? So here, this blue color is external examination, and this color is internal examination marks, right? Now these two are associated with this common y-axis, right? These two associated with this x-axis and this y-axis. So now we need to draw two y-axis. Mean that I need to have one more y-axis here. I need to have one more y-axis. This can be done. You right click on that. Go to the format data series. Format data series. Here there is one option called as a plot series on. By default, it will be a primary axis. Choose it to be a secondary axis. Choose it to be a secondary axis. If you choose a secondary axis, you can see that here we got one more. I don't need legend now. Purple AML one. Right? I will close this. Now I will access access titles, secondary vertical, right? So this is secondary vertical is internal examination marks. So what I can do it, internal examination marks. Here I can choose that. Now I will remove the legend. I don't need that. And this is sorry, purple one is sec. Which one? Access legend. This is internal. Correct. Correct. This is external examination. Right? Chart title you can add. You can add. You can add the chart title. Variation of external and internal examination marks of thermodynamics. Right? If you need format access, change it to be 1. Right? The like this same you can do it for the rest of the two. That is for mathematics and material science. Let me copy it down. Right click, select the data, edit it, external examination, everything remains the same. This is external. Click on OK. This is internal. Choose it to be internal. Right. Now change it to mathematics 3. Rather than that, again copy this, paste it somewhere else here, select the data, edit it. This you choose it for material science. And here also change it to be material science. Right. This completes the third exercise. Right? Let's move on to the fourth one. The same thing I have plotted. And these are all I have added the grid lines. Right? These are all I have added the grid lines. These are all the formatting part which I have gone in depth and in detail in the theoretical class. Right? Not going much on that. Let's move on to the next one. This is the analytical. Now, I need to draw the combination graph of variation of average temperature and wind speed over a year for Ballari city. That is, it is a combination of a bar chart and a scatter plot. It is a combination of. So everyone mute your audio. If you have any queries, then only you turn on your audio. Right now, I need to draw the combination graphs of variation of average temperature and wind speed over a year for Ballari city. That is bar chart and a scatter plot. Right. So now the fourth question. Right. For that, I have tabulated. Right. The same table I have created here. Right. Now I will go to the insert. Create a both. Hmm. Let's try to create a stack column. Let's now right click on this. Select the data. See, this name is temperature. Right. And also I will add one more. My series name will be wind speed. My values will correspond to this, right? My horizontal is this, right? Now I will select this data and can you see an option called as change chart type? Under chart design, you have option called as change chart type. Go here, choose XY scatter plot with markups. Choose the first one. Why it is second? 1 second. Yeah, stack up. Right? Stacked up. So what I can do is I can edit it. Horizontal thing I need to work on. Here I need to draw the axis titles, chart title, legends if required. Right now let me zoom it a bit. Months temperature. So what I can do is under axis title you can choose a months. Under axis title Y temperature in this you can take a variation of average temperature and wind speed over a year for Ballari city. If required, you can add a major grid lines also. Right? These are all the asterism part will come into picture. These are all the asterism part will come into picture. Right? This is your question number 4. That is, I need to draw the combination graph. Mean that I have drawn the two graphs. One is bar chart and second one is wind speed. Next question. This is how it looks. And this is the analytical how to draw it. Let's take this. Right? This is how it should draw it analytically. Next, I need to draw a scatter plot for variation of percentage. right? I need to between D retention. One sec, I need to send one very important message. Yeah, right. I need to draw the scatter plot of variation of percentage of vitamin D retention with respect to the storage days for the three trials and add their both based on the standard deviation. Right. So this is the experimental data which someone has carried out. That means he has brought some fruits and all. He has stored a number of days and he has taken because if he stores the food, it start deteriorating day by day by day. Right. So he has taken some trials and he need to draw. And now we need to draw the error bars for that based on the standard deviation. Right. Right? So this is the data which he has given. For that, we have added two more. One is average and second one is standard deviation because he has taken three trials, right? He has taken three trials. So I need to take the average value, right? For that, I will be using a function called as average, and I will choose these three. The same thing, I will take it, and I need to calculate the standard deviation. The problem which I am facing is that STDEV function is not compatible with the right, not compatible with the version which I am operating. It is not compatible with the version which I am right, which I am operating. So let's see whether I get the same result. Now I'm getting say a bit uh, different result. See this. Yeah, for entire population data. So I got a standard deviation. Yeah. Now what I can do is to put the insert, scatter plot, done. My data, series name, I can give variation of percentage D, percentage variation of D, percentage D retention of vitamin D, something I can take it. Storage days is my X and my Y will be my average. Click on OK. OK. This second access titles. Legend I don't need because I have only one. At this I can take it to be storage days, average, right? non-mole span. Now I need to draw the error bars. In order to draw the error bars, I will go to the chat design, add chat element. Here we have an option called as error bars. Here error bars are there are different methods are there. So what I'll do is I will go with the more options. Right? Error bars, I will go to more error bar options. Right? I need both. Right? I need cap also, but I don't need based on the fixed value because if it is a fixed value, it is one, or if it is based on standard deviation, there is a common standard deviation. But for the standard deviation is varying, so I will go with the custom. Specify the value. This I will choose this, and the negative error also I will choose this. Click on OK, and I need only the vertical part. I don't need this. Select this. Delete that. Right? This is how we can draw the error bars for that. So this is the one. Moving on to the next, the same thing I have shown. Now, very important question, right? A 1045 hot rolled steel tensile specimen has a diameter of 6 mm and a gauge length of 30 mm in a test fracture. The stress and strain data given were below were obtained, right? I got a load versus change in length, that is a load or that is P versus delta L, right? What he is asking here is he is asking us to calculate the modulus of elasticity, proportionality limit, ultimate tensile strength, fracture stress, true fracture stress, percentage elongation, and reduction in area. So these are the parameters which he is asking us to calculate, right? First, analytically, this we need to tabulate it. Analytically, we know that load and change in length, right? So area of the specimen we can calculate, that is pi by 4 d square. Area of the specimen at the fracture, that is pi by 4 is df square, that is diameter of the fracture. Right? Stress can be calculated, that is load by area. This is load, you can take the first load, that is 1.95 kilonewton is there into 1000 divided by that area will get me that stress correspondingly. Strain is delta L by L. I got it. Same thing I can do it for the stall and I can tabulate it and I can draw the stress strain curve. From this, we can start calculating all the modulus of elasticity is stress by strain. I got the Young's modulus, proportionality limit. I know that this is the maximum tensile stress, fracture stress, load at the fracture, percentage elongation, reduction in area. Right? So now the same thing we can work on here also. Let me open that. I don't need this all. Yeah. So this is a sample tabulation which I have created. One is D naught is the diameter of the specimen which he has given the problem, that is 6 mm, and L is the length of the bar, that is 30 mm, and the diameter at the fracture is 4.54 mm. From this, I need to calculate the area of the specimen. So we know the formula to calculate the area of specimen is pi by 4 into d square. So that is equal to, I will make use of function called as pi divided by 4, right? So let me open one more brace, that is pi by 4, right? Pi by 4 into d square multiplied by my d value is d naught cap 2, because I will be using a exponential function. I will be using the exponential function, and I got my area of the specimen being 28.27 something. The same thing, area of the specimen at the fracture, the same formula I can make use. but the diameter is not the diameter which is given in the problem. It is the diameter at the fracture, that is df corresponds to b6. So I will take b6. I got the area I got the area at the fracture, right? So now I need to calculate the stress. Stress is load by area. This load is this. I need to multiply by 1000 because it is in kilonewton, divided by area is already which I have created, and this I need to fix it. Load by area, right? I You can double click on this. I got a load, so I got the stress. Strain is delta L, that is change in length. Sorry, right. Change in length to the original length is 30 mm. This also let me fix it. Double click on this. I got my right. I got my. So what I got? I got a stress and I got a strain. Now let's draw the stress strain curve. So to draw the stress strain curve, go to the insert, scatter with smooth markup, right click this series name. You can take this. Similarly, series this. You can take it, right? Series name. You can give it a stress strain curve. For ductile material, right? You can add access titles, chart title, it is already there. Legend I don't need because there's only one. Bookman, right? This is, you can take it. This is strain. This is stress, right? This clearly shows just that for a ductile material, right? So now, very important thing. We need to go on calculating the different parameters. I need to calculate the modulus of elasticity, proportionality limit, right? So modulus of elasticity means that within an elastic limit, within an elastic limit, the stress is directly proportional to strain. That is, Young's modulus is stress by strain. Stress by strain, but if that too should be within the elastic region. First, we need to identify till what point it is behaving elastic in nature. So what I'll do is I will replicate it to identify because it's very critical for me to identify it now, right? So I will what I'll do is I will fix the format access. So maximum, let me give 0.01, right? Rather than this, right? What I am still I can reduce it to 0.005, right? We can see from this figure, from here to here, it is behaving the linear in nature. So from this point onwards, it is deviating. It is deviating. So this point we call it as a proportional point. This means the point from where it is transiting from the elastic behavior to the right. So that is 276.222. So in this figure, 276.222 is this. So let me highlight this fellow. So my proportionality limit is this. And my modulus of elasticity is within the elastic limit. Stress is directly proportional to strain. So stress by strain is my Young's modulus. Stress by strain is my Young's modulus, and the maximum ultimate centile stress is that is the maximum stress in the zone. So I can make use of a function called as max, which identify the maximum value among the selected cells. So that is 585.3365129 is the ultimate stress. And the fracture stress is the stress at the fracture. This is this. And the true fracture stress is the final diameter of the specimen is so on. So because the fracture stress which we have calculated corresponds to the original diameter, that is 6 mm. So we need to calculate the true fracture stress by considering that. So that is load divided by area at the fracture, that is 16 point something. 16 point something. This is the true fracture stress. This is a true fracture stress, that is percentage elongation, that is change in length to the original length, right? So what is the total length? The total length will be 4.2, right? Because change in length we got it. At the end, your total length of specimen will be 34.12. 34.12. So what I can take it is equal to 4.12 divided by 30. I can multiply it with 100. I got it. So percentage elongation, percentage reduction is that is same thing, right? Right? That is initial area minus final area to the initial area. So these are all the values. This is how you can solve this problem. This is how you can solve this problem. Right? And going on to the next problem. Yeah. Any doubts?
Any writing part will be there in exam or only execution in computer only, sir?
That we have clearly informed in the classroom. First, there will be a writing part, right? What is that? The analytical method is there. This you need to write this analytical method first. After writing the analytical only, we will be allowed you to enter into the computer. Without writing part, you will not be allowed to enter into the computer. This is damn clear. So first the question will be given. If the graphs are given, mean that you need to, we will provide you the graph sheets, right? You need to draw the graphs manually, and then you will be allowed to sit into the computer. Right? Sir, ನನಗೆ ಇಲ್ಲಿ write up ಮಾಡಕ್ ಬರಲ್ಲ, computer ಅಲ್ಲೇ ಮಾಡ್ತೀನಿ direct ಅಂತ ಹೇಳಿದ್ರೆ you will not be allowed, because both carries equal weightage. Right? So here that the pattern goes something like this. There will be two questions will be there. So each question carries 40 marks. That is 40 plus 40, that comes around 80 marks, and 20 marks will be there for viva voce, right? So in that 40 marks, again the split up goes 20 marks for write up and 20 marks for execution. 20 marks for write up and 20 marks for execution. So like this it goes. Any doubts?
Okay.
So next, This is the same like the earlier one, right? But this is for a brittle material. This is for a brittle material. Right? So this already this again it takes some more time for me. Wait, let's do it. What's there? Right, a tensile bar test on a bar having cross-sectional area so and so and a gauge length of so and so gave the following results. Load he has given, the change in length he has given. Right. So you can see that change in length he has given, load he has given. Right. We'll calculate the stress, that is load by area. Right. I will show it directly here. The load by area, that is load is A8 into 1000 divided by the area he has given it to be 165.4 square mm². So I have dragged it. I got a stress. Similarly, I have calculated the strain, that is delta L by L. Right. I have calculated. Now I will draw stress by strain. Extension versus load. From this figure, we came to know that till this point, it is a behavior it is showing, right? So we'll take a 12.5 load as a limit of proportionality. Limit of proportionality, and then we need to calculate the 0.15% strain. So what we'll do, we will add, right? For this, we will add 0.15%, right? We got the stress. This will add till only the proportionality limit, and stress we will take and we will offset it. We will offset it. From this offset, we will going to extend this line. We will extend this line by using a trend line function, right? Thus, trend line, you will get it in chart design, right? Here we have an option called as trend line, that is linear, right? This is a trend line. This is the more trend line options, right? 0.15 I will be extending. This already I have given forward, right? If I add a trend line, this line extends, right? Mean that this behavior starts extrapolating, and this will meet your stress strain curve at some point. You draw a horizontal line from there, right? That will meet here. That point we call it as a 0.15% proof stress. That is, it comes around 160 point something megapascal, right? 160 point something megapascal. We got it. The analytical method is there, right? So you can see that, right? This will comes around 160 megapascal, right? This I have extrapolated it. After extrapolating from here, I will draw one horizontal line where it intersects this stress value. The point where it intersects the stress value is your limit of proportionality. Limit of proportionality, right? And then this, this is critical one. This For this problem, you can refer the video which I have already uploaded in my YouTube, right? Because for explanation of this, I require minimum of 45 to 50 minutes. Right? You can refer that video. I will skip on this problem. Next. Very good. Ninth question. I need to create a quadratic equation solver in Excel by writing a VB code using conditional functions and get the roots for the below mentioned. Right? Because we know that the quadratic equation is in the form of ax square plus bx plus c, right? I need to find the roots for that. in order to find a root for that, right, there will be two roots will be there. That is, that can be obtained by minus b plus or minus square root of b square minus 4ac divided by 2a is the formula. That is, one root is minus b plus root b square minus 4ac divided by 2a is one root. And the second root is minus b minus root b square minus 4ac divided by 2a is the second root. Right? So again, we have some conditions is there. If b square minus 4ac is less than 0, if b square minus 4ac is equal to 0, and b square minus 4ac is greater than 0. These are the three conditions it should check. Based on that check, we need to write a code, right? So that can be worked on. Let me save this. Right? That can be worked out. Right? So in order to do that, first you create one tab like this, right? One is for the entering the coefficients. I will show it here, right? One for entering the tabs, that is coefficients, and second one to knowing the roots. Second one for knowing the roots. So I need to, and now I need to create the two tabs. This can be done right here. Can you see an option called as active forms? So here there is one button is there. You create one button, right? Similarly, you can create one more button. You can rename it. This you can rename it to be a solve. This you can rename it to design mode. Reset, right? Select this, right click on this. Can you see? Assigned macro for actives control. Sorry, it is not this. Let that follow because I need to insert this actives control. This is the one button, and this is the second button, right? This you can edit it. This is for solve, and this is for reset. Right click on this. Can you see option called as view code? Select that. Your VB code will be opened. Right? So before to that, one second, I will I don't save it. Right? Right? So
Yes.
now before to that, you need to write a code first. Right? I will tell you how to remember that. So first, you after creating these two buttons, first you rename it to be solve. Second, you rename it to be reset. So you right click on that solve, press view code. Here, you at this starting you will be having only these two. That is private sub command button one and end sub command button end sub. Right? You will be having only these two. In between these two, you need to type this code. You need to type this code. What does this code mean? I will tell you. I am declaring the variables. That is three variables. That is A, B, and C in order to input the values, coefficients, and x1 and y1 as two variables to store the roots. After computation, to store the roots, I will be using these two. That is x1 and y1. Right? So first, I need to input the values of A, B, C, right? right? It should be input the values of A, B, and C. So here I'm here the RHS value. Yes, tell me. Any doubt? Yeah, let me go on. This RHS value I will be assigning it to the A variable, right? So now what is this cell 6 comma 5? So mean that what is the value which is there in the sixth row and the fifth column, it will be assigning to the A variable. For example, sixth row is this. Sorry, sixth row is this, and the fifth column is this. Sorry, E this. So what is the value which I enter in this, right? It will be assigned as A. And what is the value which I assigned in seventh row and the fifth column is B. What is the value which I assigned in eighth row and the fifth column is C. So the three variables are assigned. After assigning the three variables, I need to check, as I told that I need to check the condition, that is the B square minus 4AC. Right? So I am declaring one more variable called as det, and I am calculating, that is B square minus 4AC. I am computing B square minus 4AC, and the computed value I am storing it in det. The computed value I am storing it in det. Then my logical starts. If determinant is less than 0, then no real solutions. That is, if B square minus 4AC is less than 0, there will be no roots will be there. There will be no roots will be there. So now ಇಲ್ಲಿ ಸೆಲ್ ಅಲ್ಲಿ ಏನಿತ್ತು ಅದನ್ನ ಹೇಗೆ ಅಸೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Here, what is there in the RHS, I am outputting in the cells 9,5. So mean that ninth row, fifth column, I am outputting. There is no real solutions. And 10th row and fifth column, I am keeping it to be a blank. This is the first condition. If this condition is true, then these two will execute. If this condition is false, then it comes else. Here, I am not using only else. I am using a else if statement. Again, it check the logic. What is the next logic? My next logic is determinant. If determinant is equal to 0, then why I know that one root will be minus b by 2a. So I will take x2. I will calculate minus b by 2a and assign this to x2 variable. And I will output only one root is available, that is x1 is equal to x2. And at 10 comma 5 here I will output the value of x2 which is there. Right? Next, I have one more condition, that is else, because if it is not less than 0, if it is not equal to 0, means that obviously it will be greater than 0. Then my one root will be minus b plus square root of determinant divided by 2a, and x2 will be minus b minus square root of determinant by 2a. So I am outputting x1 and x2 by 3 decimals. That is, round is a function I will be using to round off. That is, round off ಯಾವ ವೇರಿಯಬಲ್ ನ x1 ವೇರಿಯಬಲ್ ನ round off ಮಾಡಿ ಎಷ್ಟು digits ಗೆ round off ಮಾಡ್ತೀನಿ, I will be rounding off to 3 decimals. The same thing x2 I am doing, and I am ending the if statement and I am completing it. Got the point? And next, after this done, again I need to clear all the values which is there, right? So what I'll do is I will use one more function called as clear contents, right? So here range from E6 to E10, from E6 to E10. So dot clear contents. So mean that if I press that button, right, what are the values and variables which are there in that E6 to E10 will be erased off. Right? So let me close this and let's show you how exactly it works. Right? Now you are in a editing mode. You go and deselect the design mode. Right? So now I have four equations here. The first equation is x square plus 4x minus 21. So for x square plus 4x plus 21, the first a root is 1, b root is 4, c root is minus 21. Minus 21. Now you press on solve. I got two roots. I got two root. One root is 3 and second root is minus 7. That you can check it out. 3, first root is 3. 3 square is 9. 9 plus Nakamura 12. Right? 9 plus 12 will be 21. Plus 21 minus 21 will be 0. Obviously, it is correct. Right? Next, minus 7. If you take one more root, minus 7 square is 49. Plus 4 into minus 7 is 28. That is with a minus 28. So minus 28 minus 21 is minus 49 plus 49 minus 49 will be 0. Right? Now, these are all I need to select, I need to delete. Rather than doing that, I have one function here, reset. Press that. Automatically, what are the variables values which are there here will be erased off. Let's check with second. 2, 5, 10. Solve it. No real solution because in this condition, b square minus 4ac is less than 0. B square minus 4ac is less than 0. You check. B square is 25 minus 4a into c. A is 2, c is 10. 10 to the 20. 20 into 4 is 80. Right? 25 minus 80. It will be negative value. So mean that you will not be having a real solution. Reset it. 1, 6, 9. Solve it. Only one root is available. That is minus 3. Reset it. 2, 9 minus 5. Solve it. You will be having a two roots. One is half. That is 0.5. And the second root is minus 5. Right? So this is the one done. The same thing which I have shown. And an analytical method, right? You write the procedure, right? This is the one. To insert active controls code, right? After writing the code, right? You do this analytical method. As I told that minus b plus root b square minus 4ac divided by 2a. That is x2 is equal to minus b minus root of b square minus 4ac divided by 2a. Now, very important one. One second, let me see if I have uploaded this video in the earlier one. If so, let me share, link it to that. It's very simple. Let's go on, right? Right. In a typical resistor, the resistant R in ohm, right, as denoted as Y in the equation above, increases with increase in the temperature T in degrees centigrade. The temperature increment and the observed resistance values are noted down. Right, this is the temperature and the resistance in value. Right, I need to compute a straight line equation for that. That fits the this observed data, and we know that the straight line is given by y is equal to mx plus c. Y is equal to mx plus c. One is the slope and the y-intercept, right? So this can be obtained by using Kramer's rule, right? That I need to delta d1 and d2. I need to calculate it. I need x, y, x square and xy. I will calculate. That is x square is square of this x and xy is the multiplication product of x and y. I got the summation and delta. That is delta can be calculated by a mod of determinant of sigma x square, sigma x, and n. and D1 can be calculated by the determinant of sigma xy, sigma x, sigma y, and n. And D2 can be calculated as the determinant of sigma x square, sigma xy, sigma x, and sigma y. Right? After calculating all this, I can use the slope can be calculated by D1 by delta, and y-intercept, that is C, can be calculated by D2 by delta. So once if I got a M and C, I can take y is equal to mx plus C is the required equation which we have fitted. Let's practice that. Let's say this. Say least square parabola, straight line. That's the same. Sorry, same one I hope. Right here you can see that I'll, I have taken x. I have taken x square, that is a12 into a12 x square, and x into y. I have dragged it and I have calculated the summated it. Then I will be using the determinant. Just a second, delete for you to show. Right. So this is delta. Right. So this is delta. This is D1. This is D2. Right. I have taken all the values from here, and determinant can be calculated by using a function called as mdeterm. Right. I can use this function, and array is this. Close this. Control Shift. Right. Enter it. Mdeterm. Select this array, and also mdeterm. Select this array. Right. This this is D1 divided by delta. So D1 is this divided by delta is this. Calculate it, and D2 divided by delta, D2 is this divided by delta is this. I got that is M is that is slope is 0.28809, and y-intercept is 28.1227. So hence the straight line fit that observes the best data that fits the observed data is y is equal to mx plus c, that is y is equal to 0.28809x plus 28.1227. Right? The same thing you can do it. Right? This the if the value which I obtained is correct or not, I can co-validate. So let me create one scatter plot. Right? That X series I can take this, Y I can take this. Right? Roughly I'm showing. Right? This is the graph I have plotted for the data which he has given in the problem. Right? Now for this, I can fit a straight line. I can fit a straight line. This can be fitted by using a function called as trend line. I have trend line here. I can fit. I can fit a trend line, right? I need a linear trend line, right? And I need to display the equation on the chart, as well as I need to display the R square value. Means coefficient of correlation between the observed data and the predicted data. Close this, and you can fit this. I can add the legend also. Or series one, you can. Sorry, on the series, you can see. The series you can see. Um, this is observed data. You can give the observed data, right? And this is, can you see that the equation is y is equal to 0.2886. That is 0.288. We got bit because there will be some errors will be there, plus 28.074, 28.12. Right? Because here we will be using some truncation error, right? So this is how we can fit a linear curve. The next one. This is the analytical solution, how we can do it. And now find the least square parabola for the data shown in the table below. I need to fit a parabolic curve. The same procedure. You have formula, the least square parabola that best fit the sample point C, the x square plus bx plus c, wherein we will be having a three coefficients will be there and the three equations will be there. So these three equations can be calculated. That is, I need x square, x cube, x power 4, xy, and x square y. Right? After calculating all this and substituting these values, I will get three equations. These three equations, we can solve it by using any method. I will be using it by using matrix inversion method. So I am representing these three in the equations in matrix form. Then I will calculate the inverse of a matrix. Then I will get the values of A, B, and C. With these values of A, B, and C, I can fit a parabolic equation. And let me show how. Here you can see it, right? With this x, y, I have taken x square, x cube, x power 4, xy, and x square y, and I have calculated and I have summated it. From this, with using these formulas, I have calculated three equations. With three equations, I have represented in matrix form, right? And I need to calculate the inverse of a matrix, right? I need to calculate the inverse of a matrix. So, in order to calculate the inverse of a matrix, select that matrix, press F2 is equal to M inverse is the function I will be using it, and array, you select that complete, close the brace, press Control Shift Enter. Press Control Shift Enter. So inverse of a matrix can be calculated. Now I need to multiply this inverse matrix with the RHS. So select this, press F2. I will be using the function called as MMULT. Right? First choose this, then choose this, close this, Control Shift Enter. I got the values of A, B, and C. So my equation that best fit the parabolic data is y is equal to minus 0.2019 x square plus so 1.9358 x plus 2.78139. Got it? So let's confirm whether it is correct or not. So let's insert scatter plot, select the data. Let's view observe the data. X values will be this. Your y value will be this. Right? It sees that it is something like a parabola, but it is not exact parabola. So now we can fit an equation. So that is add chat element, trend line, more trending options. Right? This is polynomial in nature. Right? Because ax square this is a polynomial in nature of a second order. Of a second order. Now display equation R square value. Close this. Now you can see that I got 0. Minus 0.2019. So let me draw this figure a bit down. Minus 0.2019 x square plus 1.3585x plus 2.78 something is the best fit. So mean that the calculation what we did is correct. Right? So let me move on to the next. So you think that I'm moving a bit fast because this is only a brush up session. Right? This is only a brush up session which I have arranged. The goal seek I have already did it in detail. Let me skip on. Now solve the below mentioned system of linear equations using solver. I need to solve a set of linear equations using solver. I have three linear equations. There is 4x plus y plus z equal to 4x plus something, so on. So I need to find the value of x, y, and z. In order to do that, there are many different methods are there. For example, one of the method is which I have not posted the analytical method. Fine, no issues. No issues. Right? I can make the lower column elements as 0 by using row operations, right? By using row operations, right? And then I will get Z. From this Z, I will get Y. From this Y and Z, I will get X. Like that, I can do it. But here he is asking me to solve by using solver. He is asking by using the solver, right? Right? So I will create the tab something like this, right? Wherein I will enter the coefficients of three equations and then I will compare that, right? This solver is something like a iterative solution. It is something like a iterative solution. It goes on comparing these values, right? For example, 4, 1, 1 is the first, 1, 4 minus 2, 3, 2 minus 4. 3, 2 minus 4, and I have taken three tabs wherein I will get the values of x, y, z. And this RHS is the sum product, is the sum product of sum product mean that I will show you is equal to sum product of this, sorry, this comma this. So here I need to fix B13. Similarly, I will drag it down. What does the predicted value here, that is 4 into this plus this into this plus this into this, is the sum product. The second one, you can see that B9 to D9. B9 is this into this plus this into this plus this into this. Got the point? So, and RHS values is 4, 4, 6. 4, 4, 6. Here we have one uh, solver. You select that solver. You select that solver. If you select the solver, the set objective, you can set this starting one, right? You can don't choose this. These are all the maximization and minimization will. My voice is audible, right?
Yes, sir.
Because I have switched my eardrops. So yeah, maximum and minimum. By changing the values, mean that where the value should change. These three are the values it should change. That is from here to here. And what are the constraints? What are the constraints? My constraints are this value should be equal to this value. Add it. One more. This value should be equal to this. Similarly, this value should be equal to this. Right? Make it as a simplex method. Solve. We got the roots are 1, 0.5 and minus 0.5. Right? Now you can see that this is the iterative method. This iteration in kanala, right? It goes on with changing the values. So for this value, 446 is equal to 446. At that point, it rotates. Right? Within a second, we will get it. The second thing, let's solve it for the second case. That is 1, 2 minus 1, 1, 2, sorry, 2 minus 1, 2, 1, 4, 2, 1, 4, 3, 3, 4. 3, 3, 4, and my, sorry, I need to delete this, right? And my RHS is 1, 2, 1, 1, 2, 1. The same thing. Go to the solver. Everything is same. Solve it. I got the three roots are the three values of x, y, z are 7, -4, and -2. In the similar fashion, I can do it for the third one also. 1, 1, -1, 1, 1, -1, 2, 3, 5, 2, 3, 5, 3, 2, -3, 3, 2, -3, sorry, -3, and my RHS is 2, -3, 6, 2, -3, 6. Let's go to the solve. Everything solve it. I got my three values are 1, 0, and -1. Right? Like this, you can solve the system of linear equations using the solver. This is the 13th one. And 14th, that is all the following LPP using simplex method. But actually, this we have introduced it for 21 scheme students. Why mean that? For 21 scheme in mathematics, they used to learn OR, that is LPP. So for that, for hands-on, we have used this, but it will be very difficult for you to do the analytical method. So we remove this. And 60. Right? So there are two matrices are there, right? I need to add a matrix, A plus B and A minus B, A into B, B into A inverse, A transpose, and multiply a matrix with a scalar. So it's very, very simple. So let's see if I have that copy. Root solver demo. I don't have. Second, let's search optimization. Yeah, I have here. So I have here. So let's delete this. Into A inverse, A transpose, multiply a scalar with the matrix. Right? I have my A plus B, F2 is equal to this plus this. Control shift enter. The matrix is added. Similarly, select this matrix F2, sorry, is equal to this minus this. Control shift enter. Similarly, for matrix multiplication, we can't do A into B because we need to use a function called as MMULT. This is the first matrix, comma, this is the second matrix. Close it, control shift enter. I got a matrix multiplication. Similarly, B into A, I will be using a function called as MMULT. That is B, comma, A. Close this, control shift enter. I got B it. And for A inverse, again, I have a function called as a M inverse. Right? I will be choosing this. Close this, control shift enter. Transpose also, I have a function called as a transpose. Select, control shift enter. Sorry. Transpose. Select a matrix. Control shift enter. I have transposed. And multiplying a matrix with a scalar, select this F2 is equal to, sorry, right? I got it. Right? This is the sixth one is very simple. And 17 and the 18 is Damn simple. Right, 17 and 18 is damn simple because we need to create a Google form. Right, we need to create a Google form and we need to create a quiz. Right, this already I have uploaded in my the class. I have already uploaded. One second, let me show where exactly it is. So here only you will get it. So at the last I have this is the matrix. This is the matrix one, and here you can see that this is a quiz one. Right, this is the video how to create a user form and all everything I have explained how to do. Right, these two questions you can refer this video. Right, so this completes almost in a, for a something like a brush up session. Right, I have solved around 15 problems because the thick and thin cylinder problem I have left. You can refer in that video. Right, and these two. Right, if you still have any queries and any particular problem to be solved, any particular problem to be solved, right? You can ask me in the WhatsApp group so that I can solve that particular by arranging one more meeting, maybe tomorrow. One more meeting, maybe tomorrow or Sunday maximum. Right? Because from Monday onwards, your examination starts, right? So now let me stop sharing my screen. So if you have any queries, you can pose me. I will be there to clarify. Fix the result to. Sir, what is the command that you use to fix the result to further drag forward the results? That is absolute positioning. I will be entering the dollar, right? I will be entering the dollar, right? To make it as an absolute. Dollar A, dollar B, dollar 4. Mean that I am fixing that. So in the previous question, fourth, we need to also add secondary axis wind speed. We can. We can. Right? If you have any queries, you ask me, I will be there to clarify it. Or else, meanwhile, let me stop recording.